Have you ever wondered why coffee mugs get hot when liquid is poured in, but the same mug gets cold over time, or why the sun feels warm even though it's 93 million miles away? Today we're diving into the fascinating world of heat transfer, how heat moves through conduction, convection, and radiation. The first type of heat transfer we will be covering is called conduction. Thermal energy, or heat, is nothing more than the kinetic energy of a material's molecules bouncing around. Conduction is how heat is able to move across solid objects or touching surfaces. As a material's molecules are heated up, they start to bounce around more quickly. These molecules bump into each other, causing them to start moving even faster. This bouncing of molecules is on the microscale heat. Materials with more tightly packed molecules, like metal, have more collisions and conduct heat more quickly. Materials with loosely packed molecules will have fewer collisions and are slower to conduct heat. Let's conduct a quick conduction demonstration. If we take two dowels, one metal and the other wood, then we heat them from one end, which do you expect to transfer or conduct its heat faster up its length? At first, each of the dowels are the same temperature, but when I start to heat them up, we should see how conduction affects different materials. By looking through this infrared camera, we will be able to see the transfer of heat through the material by seeing how the color of the dowels change. The top of the metal dowel has a higher temperature because heat was able to be conducted up the metal made of tightly packed molecules faster than the wood made of loosely packed molecules. If you look around, you'll see how conduction affects almost everything around you. My coffee mug has a handle to keep the hot cup from conducting heat into my hand by giving it a longer, thinner path to conduct heat on. When I use this hot plate to heat up this pot of water, heat is transferred by conduction into the glass and then into the water that is touching the glass. But the hot plate doesn't just heat up the bottom layer of the water, it heats up all of it, right? Now it's time to dip into how heat flows within fluids. This is called convection. Warmer fluids will tend to rise up while cooler fluids settle and fall towards the bottom. As the hot plate at the bottom of the pot heats up the cooler water, the cycle continues. The circular flow and mixing of heated fluids allows the entire pot to heat up. We can actually see convection in real time by adding a dye to the water. If we take a room temperature pot of water and add ice cubes with blue food coloring, we will notice that the food coloring will start spreading into the water as the ice melts. This cold water will sink down toward the bottom, and if we turn on the hot plate, the clear water at the bottom will rise up. As the warm water rises up closer to the ice, it will start to cool down and then sink. When the cold water from the ice cube sinks down toward the bottom near the hot plate, it will warm up and then rise up toward the top. This cycle continues on and on. As we can see, eventually the convection currents allow all of the food coloring to be mixed, but as long as there is a slight difference in temperature, convection will continue. Convection affects all fluids, not just water. Air, for example, behaves in the same way. Warm air rises up and cool air sinks down. The flow of air is able to transfer a large amount of heat. On cold days, like today, this flow of air, we call wind, is capable of pulling lots of heat away from our bodies, making us colder. On the bright side, there's another type of heat transfer that can help us stay warm. This radical method of exchanging heat is called radiation. Radiation occurs when heat is transferred via electromagnetic waves. These waves are given off by anything with high temperature. The warmer the thing, the stronger the electromagnetic waves. The most obvious example is the sun. The sun is 93 million miles away and giving off massive amounts of thermal energy. There's almost nothing in between us and the sun, so the heat isn't able to transfer through conduction or convection. Electromagnetic waves are able to travel through the vacuum of space, which is able to be intercepted by the Earth and be absorbed by the air, the ground, and me. Radiation isn't just caused by massive cosmic fireballs. Heat lamps, campfires, hot pavement in the summer are all noticeable emitters of radiating heat transfer. Everything gives off some amount of radiation, even me. Most thermal radiation is called infrared radiation. The temperature camera we used earlier actually works by filtering out wavelengths and showing us a visualization of the IR spectrum. So the IR camera isn't actually showing us the temperature, it's showing us how much infrared radiation something is emitting. And that sums up our introduction to heat transfer. We hope you've warmed up to the ideas of conduction, heating through touch, convection, heating through flow, and radiation, heating through waves. We'll see you next time, and remember, challenge everything.